Here, example 8 of finding the area of regular polygon. In this case, we are given another regular hexagon, but we are given the perimeter along with it now, which is 48 feet. This is a regular hexagon, so that means all sides are going to be the same. All sides are going to have the same value, so we can just go ahead and take this perimeter, which is 48 feet, and divide it by the amount of sides that we have, which is 6 sides. So 48 divided by 6 is going to give us 8. So this over here is 8 feet. And same thing all the way around. Of course, the formula for the area of any regular polygon is still the same, which is the product of 1/2 the apothem and the perimeter. But we don't know the apothem, which is denoted in the red. So we have to find that. To find the apothem, again, cut this regular hexagon into a few triangles by connecting the center with each of the vertices, or the corner point, or the point where the circle and the regular hexagon. And now find the degree of all the angles in all of these triangles. So starting at one point, go all the way around, we got 360. Because this is a regular hexagon, we can go ahead and take the total angle, the total degree 360, and divide it by how many angles that I'm drawing right here, which is 6 angles. So 360 divided by 6 is going to give us 60 degrees here for each of these angles. Like that. Well, also remember that by the definition of regular polygon, because this is a regular hexagon, we know that not only is it equilateral, it is also equal angular. So this angle here is the same as this one, is the same as this one, same as this one, same as this one, and same as this one. By the same theorem called the alternate interior angles theorem, if this angle is 60, then this angle here is also 60. If this is 60, this is 60. By the angle triangle sum theorem, if this angle is 60, this is 60, this also has to be 60. And same thing for this one. And of course, you guys know that all of these angles are all 60 degrees by the same reasons. Like that. So all angles are 60 degrees as usual. So we can go ahead and try to find the apothem by considering the bottom green triangle and just go ahead and take the left half of it. Remember that the apothem and the side of this regular hexagon intersect each other perpendicularly, so that's going to be the right angles right there. Taking the left half of this bottom green triangle, we are going to have something like this. That this angle is 90. This angle here, which is this one, is 60. And this angle here, which is the left half of this entire angle, is going to be 30. So not only because this angle is bisected by the apothem that creates this half being 30 degrees and this half being also 30 degrees, it is also because of the triangle angle sum theorem. If this is 60, this is 90, this has to be 30. So that all angles added together equal to 180 degrees by that theorem. Now, by the 30, 60, 90 triangle theorem, opposite to 30 degrees is the short leg denoted by a variable, call it x. Opposite to 60 is this long leg, which is the apothem denoted by the product of the short leg multiplied by square root of 3. And opposite to 90 degrees is the hypotenuse in the green, which is the radius of the circle, denoted by the formula 2 times x. Now we know that each side of the regular hexagon is 8 feet, but this base of this triangle is only half of this side of the regular hexagon, so we know that x is going to be equal to 4 feet. Well, if x equal to 4 feet, we know this long leg here, which is the apothem, is going to be equal to 4 times square root of 3. So this is the feet. This is the apothem right there. So just go ahead and plug in the value of the apothem. So we got 1/2 multiplied by 4 square root of 3 multiplied by 48. Like that. Well, 2 goes into 7 goes into 4, so simplifying it now, 2 divided by 2 is 1, 4 divided by 2 is 2. 2 times square root of 3 times 48 is the same as 2 times 48 times square root of 3. Well, that's going to give us what? Capital A equal to 96 times square root of 3 feet square. This is the area of this regular hexagon.